All right, in this video, we're going to take a look at the area between two curves using integrals. So if we have an area like this, where we want to find the area between these two curves, between this parabola and this line, we can find that area by subtracting the two uh, functions, f of x and g of x, and taking the derivative. And we just got to watch out. We got to make sure that we subtract the taller one minus the smaller one, because we'll get the appropriate area. If we go the other way around, we get a negative area. Now it actually works okay when it goes below. All right. So whether this graph, this shaded area is just above the x-axis, or if it goes below the x-axis, either way, it works just fine. So we're going to subtract the large minus the small. The reason why it works fine is because, below is a negative area, so we have a negative area minus a negative area, basically, and that gives us this, okay? So we're going to go here, we're going to go find the integral of, now, this is our parabola, so that's going to be our f of x minus g of x, which is the line, dx. And we've got to find out where they intersect. So this guy is at -1, and this intersection is at 3. Okay? So we're going to go from -1 to 3. Okay? So let's go ahead and just write this out. We've got f of x minus gx. Now be careful. Make sure you write these in parentheses, because this is going to affect things with that negative. So easy thing to forget. So again, still going from -1 to 3. If we clean this up, we've got 4 minus 1, which is 3. I've got x minus negative x, which is going to be a 2x. And then a negative x squared. All right. And we should be able to integrate that. All right. So we've got 3x plus, it's going to be 2x squared divided by 2. It's going to cancel out that 2. And then minus x cubed all over 3. Now we're going to evaluate that from -1 to 3. So at 3, we have 9 plus 9 minus 27 divided by 3 is 9. Now substitute -1. We get -3 plus -1 squared minus, and then we have -1 cubed, which is -1 divided by 3. So let's see. Those are going to cancel. We've got 9. Distribute this negative. Plus 3 minus 1. We can put those together at any time here. Yeah, why not? Let's go and put those together. This together, instead of distributing, either way would be fine. So we've got -2 plus a third, so that would be plus a -1 and 2/3. Okay, or -5/3 there. So we have 9 plus a -1 and 2/3. That's going to be 7 1/3. Okay. There's our area. All right. Cool. All right. So that's the area between two curves. And again, these are functions of x. So in our next example, we're going to see what happens when we have a function of y. So here we have a function of y. Well, you can see if you look, these graphs look a whole lot like what we just did. And so when we integrate this parabola, when we integrate 3 minus y squared dy, so that is the area between the parabola and the y-axis there, okay? So that's the area between the y-axis, not the x-axis now, because we're going dy, okay? And so we need to take that, and we need to subtract off this other area here for this kind of a yellow curve, okay? And so that subtracting off the yellow curve, okay? And the area between the line and the y-axis, that's going to give us the integral of y plus 1 dy. And we want to take the blue thing minus the yellow thing, okay? And that would leave us with just this shaded green area. Now again, down here we're going to have minus a negative, which is going to give us a positive, because this would actually be negative area part of this integral, but we're subtracting these two things, and so it'll work out just fine. So let's go and put that together to one integral. So we've got the integral of 3 minus y squared, and we'll put that in parentheses, minus y plus 1 dy. And we're going from, now the y values where they intersect, remember we're talking y now, okay, so y values are negative 2 and 1. Okay, so we're going to integrate this from negative 2 to 1. Looking at the y values, not the x values. Okay? Now, we've spent a lot of time with x values. Y values kind of different. You kind of have to just flip over the page or flip over your mind a little bit there. Okay? So we have, cleaning this out, there's going to be a negative y squared. There's going to be a negative y with 3 minus 1. There's going to be a 2. All right? Now we're going to use the first fundamental theorem of calculus. Take the antiderivative, 2y minus y squared over 2 minus y cubed over 3. We're going to evaluate that from negative 2 to 1. Okay? So substituting 1, we get 2 minus a half minus a third. Minus, substitute negative 2, we get negative 4. And that's going to be a minus 4 halves, which is obviously 2. And then we'll get minus negative 8 over 3. Ugh, kind of ugly. That's all right. Let's see what we can do here. So, this gives us, what do we got here? This is 4 halves. I don't know. This is 3 halves. I'm going to leave that 1/3 alone for the moment. See what happens here. Minus, this is negative 8 halves minus 4 halves, so that's negative 12 halves, I guess also known as negative 6, huh? Now we got to actually, that's minus negative because of this negative here, okay? And this is a plus 8/3 because of this negative out here. We're going to make this minus 8/3. Hopefully this will clean up nicely for us. So let's see, we've got 15 halves. And then we have negative 9/3, right? That is kind of nice. All right, so we have 15 halves minus 3. So 7.5 minus 3, 4.5 is fine. Okay. All right. So there's the area between the two curves. It came out to be positive, which is good because area has to be positive. All right. So that's the idea. So once again, when we have graphs that are one above the other, we subtract top minus the bottom, or if they're left and right, you want to take the right-hand most minus the left. And again, that's talking about in a line. So if you were to pick a line, any line would do. And so which one is farther to the right minus the left? So right minus left, because right numbers are larger minus smaller numbers over on the left. Okay? So either top minus bottom or right minus left, that'll give you the area. All right, good luck.